Hello guys, welcome to my video series tutorial to talk about Microsoft Semantic Kernel Agent Orchestration. In this video, we are going to see the third pattern called the concurrent pattern. So far, we have seen two main patterns, one for sequential pattern and another one for group chat pattern. So in this video, we cover up concurrent pattern. So what is concurrent pattern? What is concurrent pattern? A concurrent pattern, multiple agents work in parallel on the same input. That means how it works. All agents receive the same input at the same time and work independently. So the execution, your same prompt, it will execute different agent in parallel simultaneously. What is the use case? Why I need to implement this concurrent pattern? In what scenario I have to choose this concurrent pattern? Simple. When different ideas or point of view useful for scenario, you can use this concurrent pattern concept. So example, if you want to use brainstorming ideas or summarizing from different angles the content, that time you can use the concurrent pattern. So the final output results from each agents are collected and combined, we get one final output. All the agent executed, then all the agents output collected, and the collected in output sent to the user or developer, whatever it is. Let's move on to our IDE and we implement one simple concept, use this concurrent pattern. In this example, I have created three agents related to movies, one for action fan and another one for romantic comedy fans and another one for classical fans. So three different agents. As a user, I send you a prompt. I need a suggestion some good movie for this weekend. For in this scenario, user suggested good movie, but we don't know about they are fan of romantic or action or classic. We don't know that. So what we'll do, we send the same prompt to the available agents, action agent, romantic comedy agent, classical fan agent. We send this prompt to the agents. We collected all the output from them and response to the user. That's our idea. So here I have created three agents. So as I mentioned, and so here I added the runtime. Now we have to create the concurrent pattern. To implement the concurrent pattern, Semantic kernel provides the class called concurrent orchestration. Concurrent orchestration, we have to use this class, and here I define my variable name concurrent orchestration, new of concurrent orchestration. We have to pass agents. I just remove this one. We can keep simple, and here I have to pass the agents. I have three agents: classical agent, action, and romantic fan agents. So these are all we passed. And if you want, you can implement a response callback also. At the moment, let it be there. We come with this one in the next topic. So here I created, and next step we have to invoke this agent. So invoke this one here. I add where result equal to concurrent orchestration dot invoke async. So this is async function. We have to add a wait here. Wait. So the first argument we have to pass the input. Input we have to pass, that means our prompt. The second argument is the runtime. The runtime we have already created, so we use this runtime object. So this is I pass it here, runtime. So here I have to pass the input. So here I declare my input where input, as I mentioned, suggest a good movie to watch this weekend. And maybe you can add the language also, which language you are interested to watch the movie. I mentioned in Tamil. So that's it. So here we have to pass the input. So we created the concurrent orchestration and we call the invoke function, pass our input and runtime. In this result, we get the output. So finally, we get the result here. So where agent result wait result dot get value async. So if you see this output written here is a string array. Previously we seen the sequential and a group orchestration, it's a written string, but for this concurrent orchestration written as an array, because as I mentioned, all the agents output collected and sent back to the user or developer. So that's the reason we get the array of string here. So we just display the result using for each. So where you just remove this one, we add agent, and here we print console dot write line agent message agent. That's it. So we run this application and see the result. I put the so the agent, it won't be issue. Yeah, I created, so it's not an issue here. So we run this one and we'll see the output. So start the application. Application started. Here you can see the hello concurrent pattern. Yes. Yeah. So here we get the output. So if you're in the timeless classical, it's 1966 movie recommended, and another one recommended watching 2022. Okay, and this one is a romantic comedy. Yeah, this is a romantic comedy. Oh my God. Okay, this is a simple example how to implement this concurrent pattern. And stop the application, and we just enable this callback also. What we'll get callback, actually using this scenario, I feel callback is not more value added here, because the result from agent output and this callback result almost same only. We just confirm it. So I added the callback here. So the callback, this one we have already function response callback. Yes, so added, and here we printed the author name and content. Yeah, we restart the application. Bug. Yes, I forget to add semicolon. Restart again. So romantic comedy fan, action fan, classical fan. So here you can see the output same only. For timeless comedy recommended Moonram Pirai here 1982, the same classical fan, the output same. So based on the situation decision, you can implement this callback for concurrent orchestration.